Every day, millions of Americans drive cars that over time have become increasingly fuel efficient. Almost all of those vehicles have one thing in common that allows for this efficiency: the turbocharger. The turbocharger is a device attached to an engine that helps cars use fuel more efficiently by forcing more into the engine, leading to increased combustion. Today, from family sedans to supercars, turbocharging has become the norm of modern driving as it is today. But this was not always the case. In the early 1970s, the American government had a problem. The air quality in many major cities was so bad that visible smog layers blanketed many urban centers, leading to major health concerns. A major culprit: automobile emissions and leaded gas. American consumers also had a problem. Due to an international oil crisis, they faced long gas lines, unreliable cars, and rising gas prices. That meant the U.S. automotive industry had three competing problems: compliance with new government regulations for vehicle emissions, improving automobile engine performance, and satisfying consumer demand for improved fuel efficiency in automobiles. Ultimately, it was this dilemma that forced automotive engineers to come up with a solution that required rethinking engine designs, leading to one of the most revolutionary shifts in automotive industry: forced induction and turbocharged engines. The commercial production of forced induction via turbocharging in internal combustion engines in the 1970s revolutionized the modern automotive industry, leading to comprehensive reform in engine designs that today has become a standard feature in car manufacturing. Ever since the end of World War II, American car manufacturers and consumers both prioritized performance over fuel efficiency. This was because at the time gasoline was cheap, with the U.S. Department of Energy recording gasoline at less than 40 cents per gallon during the 50s and 60s, allowing consumers to favor high horsepower engines like V8 engines without worrying. This system worked well for consumers, as during this time period, many people began moving to suburban areas, commuting large distances, starting families, and traveling more for leisure. Because of this demand for large, comfortable, and high-performance cars increased, this led to manufacturers profiting off of spacious vehicles designed for comfort and power rather than fuel efficiency. However, this system began to change in the 1970s. Public awareness of environmental damage increased as thick smog began covering major cities like Los Angeles, where automobile emissions were identified as the main cause. In response to this concern, Congress passed the Clean Air Act of 1970, which puts limits on vehicle emissions. Automobile manufacturers were now required to change their engine designs to allow for these changes. At the same time this was occurring, the government mandated the removal of lead from gasoline due to its public health effects. Lead, which has been previously used to raise fuel octane and prevent engine knock, was now banned in fuel. Because of its removal, engines were now more prone to knocking, and automobile performance was limited. These shifts made catalytic converters, devices used to reduce exhaust emissions, mandatory since leaded gasoline destroyed them. As a result, all automobiles had to run unleaded gas, placing even more restrictions on performance. And in 1973, the pressure on the automotive industry intensified when the Organization of Petroleum Exporting Countries imposed an oil embargo on the United States in response to its support of Israel in what is known as the Yom Kippur War. Because the U.S. was really dependent on foreign oil, the embargo led to massive reductions in gasoline supplies, which caused fuel prices to spike and led to widespread shortages. Across the U.S., Americans waited in long gas lines, gas stations ran out of fuel, and Americans for the first time began to comprehend the idea that gasoline could be limited or expensive. In response to the embargo, Congress passed the Energy Policy and Conservation Act of 1975 and also created the Corporate Average Fuel Economy Standards, regulations that forced automobiles to maintain a minimum fuel efficiency. Because of this, manufacturers were now legally required to improve their vehicles' fuel efficiency. These combined pressures on manufacturers forced the automotive industry into a corner, where in order to not sacrifice performance and meet expectations, engineers were forced to search for solutions that ultimately led to engines to survive in a changing world. The solution engines turned to at the time was turbocharging, a form of forced induction that allowed engines to keep their performance and meet standards without increasing their size. Although turbocharging became widely used in cars during the 70s, the idea itself dates back to 1905. When Swiss engineer Alfred Bucci patented a system that used exhaust gases to force more air into an engine. For most of the 20th century, turbocharging wasn't considered in automobiles and was instead used in aircraft and industrial machines. As manufacturing improved, turbocharging became viable for passenger vehicles. Turbocharging works by capturing exhaust gases that would otherwise be wasted and using them to spin a turbine connected to a compressor. This compressor compresses the air and forces more air into the engine cylinders, thereby allowing more fuel to be burned and increasing engine power. Because of this effect, turbochargers allowed smaller engines to perform with similar output to larger engines. Because of this, turbochargers directly address the challenges manufacturers faced in the 70s: emissions regulations, fuel economy standards, and removal of leaded gasoline limited engine performance. While consumers still had expectations for power and reliability, turbochargers offered a solution to all these problems by improving efficiency and restoring engine performance. Early turbocharged cars demonstrated this. The BMW O2 Turbo, introduced in 1973, showed that forced induction could boost performance in a road car. Later, the SAB99 Turbo, released in the United States in 1978, proved that turbocharging could be reliable and practical for consumers. These cars helped the public perception by showing that forced induction was beneficial. As public perception grew, manufacturers began adopting turbochargers as a practical solution. By integrating turbos into consumer vehicles, manufacturers began downsizing their engines while great performance results. This marked a shift in the automotive industry, setting the stage for turbocharger adoption. Immediately following their introduction in the late 1970s, turbochargers changed the game for balancing performance and fuel efficiency. Turbocharging helps fuel efficiency by allowing manufacturers to replace large engines with smaller ones without sacrificing power. One of the first turbocharged cars sold in the United States was the SAAB 99 Turbo in 1978, which used a four-cylinder engine to deliver performance on par with larger engines while consuming less fuel, which was extremely appealing to consumers at the time due to gas shortages and rising prices. American manufacturers also quickly adopted turbocharging. General Motors, an American automobile manufacturer, through its sales of the Buick, became the most successful American producer of turbocharged vehicles in the late 70s. By 1978, Buick was manufacturing tens of thousands of cars with turbocharged engines, making it the largest seller of turbocharged passenger cars in the U.S. at the time. Over time, sales numbers continued to increase, with the SAAB 99 turbos selling worldwide and Buick's turbocharged cars remaining in production demand, proving that turbochargers were effective solutions at the time. In short term, turbocharging provided it could satisfy manufacturers, consumers, and the government. Consumers regained power with increased fuel efficiency, manufacturers met emissions and fuel economy requirements without losing sales, and government got its demands met. This success confirmed that turbocharging was a viable solution at the time, allowing for its adoption even through the decades that followed. Today, the turbocharger revolution has become the standard in American car manufacturing. As emission and fuel efficiency standards continued to increase in the decades that followed, turbocharging became an essential part of vehicles. Throughout the decades that followed, automakers adopted engine downsizing, replacing larger engines with smaller turbocharged ones to meet CAFE standards. For example, the Ford F-150 shifted from large V8 engines to turbocharged V6 EcoBoost engines in 2010s. During this period, manufacturers like Chevrolet, Honda, and Toyota also integrated turbocharged engines into their cars, showing that turbocharging had become a standard rather than a short-term solution. Today, turbocharging is the standard in majority of American vehicles. It plays a crucial role in meeting governmental emissions and fuel economy pressures. In 2019, the U.S. Department of Energy released a study stating that 34% of all new light-duty vehicles produced were equipped with a turbocharger, a significant increase compared to 1% in 2000. From the gas crisis of the 70s to the cars we drive today, turbocharging sparked a revolution that changed engines forever. And now for the professional, we interview Professor Sam Akerst from the University of Bath, a professional in internal combustion engine technology and turbo machinery.
The main reason for adopting turbochargers for automotive, so passenger cars, is really fuel efficiency. So although they increase the power, you can then put a smaller engine in. So rather than having a 5-litre V8, you could have like a 3-litre V6 turbocharged, or even a 2-litre 4-cylinder engine turbocharged. You can get the same amount of power, but you're doing that by recovering the exhaust energy.